5.5, more on identities. In this section, we'll do two main things. We'll work on simplifying expressions that involve trig functions, and we'll talk about verifying new identities other than the fundamental ones. An important technique is writing everything in terms of sine and cosine. For example, let's simplify cotangent of theta over cosecant of theta by writing them in terms of sine theta and cosine theta. Cotangent of theta is cosine of theta over the sine of theta, and cosecant of theta is 1 over the sine. We invert and multiply to get cosine of theta over sine of theta times sine of theta over 1. Then the sine of thetas cancel, leaving us cosine of theta, which is much simpler than cotangent over cosecant. Example 2. Write secant of theta in terms of sine of theta only. The secant of theta is 1 over the cosine of theta, and the cosine of theta is plus or minus the square root of 1 minus sine squared. Without knowing more about theta, such as which quadrant it's in, we have no way to choose between the plus and minus, so we just have to leave it in the answer. More on simplifying. Let's simplify sine of theta over cosine of theta plus cosine of theta over sine of theta. To do the addition, I need a common denominator, which will be the cosine of theta times the sine of theta. So I multiply the first fraction by sine of theta over sine of theta. That's multiplying sine of theta over cosine of theta. Then we have plus. The second fraction I'll multiply by cosine of theta over cosine of theta. So then we have times cosine of theta over sine of theta. Doing the addition now, we have sine squared of theta plus cosine squared of theta over sine of theta times cosine of theta. And because sine squared plus cosine squared is 1, we replace that expression in the numerator with a 1. So we have 1 over the sine of theta times the cosine of theta. Next example. Let's simplify 1 plus the cosecant of theta times 1 minus the cosecant of theta. Now using a plus b times a minus b equals a squared minus b squared, we get 1 minus cosecant squared of theta. And that is equal to minus the cotangent squared of theta. Now how did I get that? Well, using the identity 1 plus cotangent squared equals cosecant squared, if you were to subtract cosecant from both sides and also subtract cotangent from both sides, you would get 1 minus the cosecant squared of theta equals minus the cotangent squared of theta. Next example, factor and simplify. Factoring on top, that's the difference of squares. It's an a squared minus b squared because 1 can be thought of as 1 squared. We get sine of theta minus 1 times sine of theta plus 1. In the denominator, there's a common factor of tangent. So we factor it out and get tangent of theta times sine of theta minus 1. Now we can cancel the common factor in the numerator and denominator of sine of theta minus 1 leaving us sine of theta plus 1 over the tangent of theta.